afternoon, everyone. Welcome to the summary session for this course on Essentials of Data Science with R software. I am Shreya, one of the TAs for this course, and today I'll just be brushing up on all of what we have discussed in this course so far, and I'll end with a practical implementation of the concepts discussed during the last few weeks in R. So, yeah, so let's start. So, first of all, I'll just touch up and give a brief recap of what we have learned so far. So, we started with sampling techniques. We learned about sampling techniques. The most primary thing that we learned about was simple random sampling. Okay, and that could be of two types. That could be with replacement, and it could be without replacement. So in each of the possible scenarios, we learned how to, if y1, y2, yn is my population and y1, y2, y small n is my sample. So we learned how we can estimate population mean mu with the help of the sample. So sample mean will give us an estimate of the population mean, and then we learned about the variance of y bar in case of SRSWR, what it will be, in case of SRSWOR, what it will be. Okay, and also we tried to get a confidence interval for mu based on the sample in hand. Then we learned about techniques. So these simple random sampling is actually applicable when you just want to randomly sample from a pool of sampling units such that all the population, every aspect or every feature of the population is somewhat captured in your sample randomly. Okay, then we got to know about stratified sampling. So stratified sampling is a technique where we have the population is somewhat subdivided into or stratified into pockets, where these pockets, there is a distinctive feature which can divide the entire population, and then from each of these subpopulations we draw a random sample and then make inference about the population mean. So this is what we call as stratified sampling. Then we learned about allocation of sample sizes to different strata. So once we have these different strata, we can how do we choose the sample? So we could go for equal allocation, we could go for proportional, okay, and we could go for the Neyman allocation or the optimal. So in case of equal allocation, we would choose equally from different strata. Proportional is that we choose based on the proportion in the population, and in case of minimal or optimal allocation, we consider the size of the strata, okay, that is Ni, and the variability as well. Okay, proportional, we only consider the size of the strata. Okay, so we learned how to allocate different sample sizes to different strata, and then we, from each of these strata constructed or determined, we would do a simple random sampling with or without replacement to ultimately get an estimate of the population mean and an estimate of the the variance of the estimator of population mean. Alright, then after that we learned about a technique which is actually called a bootstrap technique. So we learned bootstrapping and why it is necessary. It is necessary because sometimes it might so happen that the form of variance is not analytically deducible very efficiently or quickly. So in those cases where we are interested in a statistic whose variance calculation is not straightforward, so in those cases we use bootstrapping as a way out. Okay, and it is a sort of a resampling technique. Okay, so in this case we have an original sample S, and from here we draw perhaps 10 bootstrap samples, and then based on these samples we would get an estimate of the variance. Okay, so if we are interested in calculating the value of some statistic, we resample from this original sample into 10 bootstrap samples, we get the value of the statistic here, and then we calculate the variability in these bootstrap samples, and that is reported as the variability of the estimator. And then that is actually used for further inference. Okay, right. So once we learnt all of these, then we learnt how to get the confidence intervals for the bootstrap techniques. And then we learnt about regression analysis. In regression, we learnt about simple linear regression. We learnt about multiple linear regression. We learnt about the OLS techniques, the maximum likelihood techniques of estimation, and then we learnt about test of hypothesis. We learnt about ANOVA, that is analysis of variance, and then finally we learnt about some other regularization techniques like ridge and lasso. Alright, so this was a recap of everything that was covered under this course. I hope the sessions have been useful for solving the assignment problems. So today I'm going to show an R implementation of a regression problem that might help you in handling questions from regression analysis. Okay, so let's just start. So first I'll open my R console, and I hope this is visible. Okay, so here the question is based on a data set called Boston, which is available under the mass package in R. So let us just try and do this. So I'll just remove these. Okay, so we load library mass because it is known that yes, so we load this library mass and then try to see and explore the Boston dataset. So this is how, if I type Boston, this seems like a data frame. So I'll just look at the structure of this thing. So let me just write str. So as I was saying, this is actually a data frame of 506 observations of 14 variables. And which are these 14 variables? These are the ones given by dollar: CRIM, ZN, Indus Gas, so on and so forth. Okay, so if I want to find out what is this dataset all about, let me just go to Boston and press F1. So this data frame is actually housing value. This actually demonstrates housing values in suburbs of Boston. And what are these variables? These descriptions are given here. So CRIM is per capita crime rate by town. ZN is proportion of residential land zoned for lots over 25,000 square feet. Indus is the proportion of non-retail business acres per town. CHAS is Charles River dummy variable. So it's 1 if tracts bound river, 0 otherwise. Okay. This is nitrogen oxides concentration parts per million ppm. average number of rooms per dwelling, age, proportion of owner occupied units, weighted mean of distances, index of inaccessibility to radial highways, tax, full value property tax rate, PT ratio, pupil teacher ratio, black is some other continuous variable, LS stat is lower status in percentage, and MDV is median value of owner occupied homes. We can find further details in here. Okay, so once we have this data set, which is actually a data frame, let us just see what are the questions. So the first question was load the Boston data set and display the first 6 rows. So let me just copy from here, and then so if the question is this, load the data set, we've done that. This is what we do to load. Okay, so I don't think I need to do this. This Boston is fine. Alright, so this is loaded, and display the first 6 rows. So if I do head of Boston, I'm going to get the first 6 rows. 1, 2, 3, 4, 5, 6. Okay. Alright, so the next thing is how many observations and variables are in the data set. What do the variables represent? So how many data set and observations? So I can see here, if I press F1 on line 4 for detailed description, or I did a str, so this also gives me the number of observations and number of variables. So I have observations, I have here equal to 14, sorry, observations are equal to 504, and variables equal to 14. Okay. Now moving on, let's see, visualize the relationship between median home value and other continuous variables. Example, CRIM, ZN, index, noc. So in order to do this, let me choose which are the continuous variables. So here we are actually, let us first see which are the continuous variables in this data set. So here if I do an str, we see that the first 3 they seem like continuous variables. The fourth one, CHAS, if we see from their description, this is actually a dummy variable. So we don't want this variable as a continuous variable. So let me just first write down here within comments which are the dummy variables or not continuous. So these are like the discrete variables. This is CHAS. The other discrete one that I can see seems like this RAD. So we'll just check what RAD represents. So this also represents index of accessibility to radial highways. So since this is an index, this can be considered as a discrete variable also, and also as an ordered ordinal variable. So for the timing, let us consider this as not continuous and keep it as a discrete variable. Then we have here something, no, these two seem like the only non-continuous variables. So let me just first prepare a data set. So data2 equal to Boston, and then I want to have the entire data set without these two. So I'm going to remove these and let me see if I can get the data set too. Oh no, invalid argument to unary operator, so I won't be able to get this. So what do? I take all the rows and then I have to remove these two variables. That is what I want. So this I'll just see what are their indices. So this one seems like 1 2 3 4 5 6 7 8 9. So 4 and 9 I want to remove. So if I do minus C 4 and 9, okay, I have 12 variables now. Let me just look at their call names. So see, here we don't have the two variables that we were talking about. Now we want to visualize the relationship between MEDV and other continuous variables. So I could do pairs. So pairs of, if I give data 2, this is what I get, a 12 cross 12 matrix. But I am not interested in this. I am interested in the relationship between MEDV and the other variables. So let me just do a basic plot. So I'll do data2 $crim, data2 $MEDV. So this is how it looks like. Similarly, I'm going to do, so I need to have there are 12 variables. I should be having 11 plots like this. So I can do it like this, or I could even use a loop. Data2 $MEDV. Okay, so similarly I could see how each of these variables look like. All right. RM. Okay, this looks like a nice plot. Then with age, this is how it looks like. Then with other, this fine. With tax, this how I should be having 11. So with PT ratio, This is how it looks like with the black. Okay, the LSTAT. Okay, I think we have done 1 2 3 4 5 6 7 8 9 10 11. So 1 2 3 4 5 6 7 8 9 10 11. This is done. So if I want to visualize everything at in one area, I can do this thing. I want to write partition. I want to partition this space into let's say 4 columns and 3 rows. So I'm going to write par mf row equal to c, so 3 rows and 4 columns, and then I am going to run all of these together. Plot new figure margins too large. So what do I do? Let's see what Google says. So if I do this thing, if I write yes, so this is how I am visualizing each variable with respect to each other variable. I can add xlab and ylab, or a main equal to medv versus crim, let's say. So this main is going to add a title to each of these plots. So if I just remove this and then try running all of this once again, so this is how the title is going to come. So if this is medv versus zn, okay, and so on and so forth. So on my y-axis I have this medv variable, and on my x-axis I have all the other continuous variables. So we see for here, as this variable increases, the medv decreases, so there seems to be a negative relation. Similarly for this one, as medv is as this variable on x-axis is increasing, medv seems to increase. Similarly for this one, as we increase along x-axis, y-axis seems to increase. So this one seems like a negative relationship, this seems like a positive relationship. So this is how we are going to visualize using plots or pairs wherever possible. Okay, now the next question that we have is this thing. So the question is, create a correlation matrix for the continuous variables. What variables are most correlated with medv? So if I do a chord plot of this data 2, so correlation plot, how do I do it? Okay, so let's find out correlation plot, how it is done. Here I should be supplying the correlation matrix. Okay, so first let me just find out the correlation matrix. So I have, if I write correlation of data 2, okay, even then they are saying that this is not found. So maybe this requires the library core plot. Okay, alright, I should remove this because I just made a partition out of this. So library core plot and this one, this is actually giving us, so we should be focusing on what variables are most highly correlated with MEDV. So we should be focusing on the last row and last column. So here wherever we have very deep red or very deep blue, those are the highly correlated. So highly correlated could be positively correlated or negatively correlated. So based on the size of the circle and the color of the circle, we can say that this is highly negatively correlated with LSTAT and positively correlated with RM, slightly positively correlated with Zn and slightly negatively correlated with the others. Okay, so apart from this plot and doing this simultaneously, we can also do something like pairs, and then we'll have to give this one MEDV plus all of these CRIM plus let me just write data $2 MEDV plus data $2 CRIM plus data $2 this thing plus this thing, and then we are going to get this sort of a matrix plot. Alright, so here whatever we did previously, we would have concentrated only on the first row and first column because that corresponds to the relationships between MEDV and the others. Alright, so these are like different options to do it. So this is way 1, this is actually way 2. Alright, now once we have this score plot, we can comment that this is actually MEDV is actually highly correlated with RM and negatively correlated with LSTAT. So let us see how the plots look like. This is with RM, positive correlation, and this is with LSTAT, a negative slope, negative correlation. Okay, so here I write positive correlation, high positive correlation with RM and high negative correlation with LSTAT. Okay, so then comes the next question, which is this thing. Fit a simple linear regression model predicting MEDV using CRIM, that is crime rate. What is the equation? How significant is the coefficient for CRIM? So we have to plot a simple LM. Okay, so my Y is this one, MEDV, and X is nothing but CRIM, and data equal to, let me put Boston, or data to, let me put Boston. So if I run this, this is the fitted regression equation. So the equation is y hat equal to 24.0331 minus 0.4152 CRIM. Okay, this is the regression equation. Now, how significant is the coefficient for CRIM? So to test for significance, let me write this as model. I am going to write summary model. Okay, so summary model is this thing, and here we see that the how significant is the coefficient for CRIM. So here we see that the p-value is equal to of CRIM this will get us model dollar coefficients, no, this one will get us model dollar okay, we will just write it down for the timing. So this is the p-value, p is equal to this thing, okay, which is way less than 0.05. So we reject null h naught. H naught was what? We reject null h naught, that coefficient is not coefficient equal to 0 versus h1 not h1. So this was my hypothesis, and the p-value is less than 0.05. So the decision is reject h naught and conclude that the coefficient for crime rate is significant. Okay, fine. So once we have this, let's move on to the second question. So here they are saying interpret the slope and intercept of the model. So we have a positive intercept and a negative slope. So positive intercept or non-zero intercept means what? It means that even if crime rate is 0, MEDV will be 24.03311. Okay, and units. So what is the unit of So if I go and check this Boston thing, MEDV is what? Median value of owner occupied home in 10,000. So even if there is no crime rate in that area, median value of owner occupied homes is 24.03311. So into 1000 and that is the amount in dollars. Okay, so this is the interpretation of the intercept, and the slope coefficient is negative. So what that means is that for 1 unit increase in crime rate, that is, what is the crime rate called? For 1 unit increase in per capita crime rate, price, or I would rather say median value of owner occupied homes will reduce by this into 1000 dollars. Okay, so this is the interpretation of the slope and the intercept of the model. Now the next question is, what is the R squared value and what does it suggest about the model's performance? So from here we see that R square is actually R square value is 0.1508, which seems like low. Okay, so this is not a good fit. Model's performance is not that good. Okay, so this is the interpretation. Now the next question is, plot the regression line on a scatter plot of MEDV versus CRIM, crime. So let me just, if I just write plot Boston, so on x-axis I am going to have this one, crime rate, and on y-axis I am going to have this MEDV. Okay, this is what the plot looks like. Now I have to plot the regression line on a scatter plot of MEDV plus CRIM. So to overlay a regression line, I will write abline model and then I'll give it a separate color. So if I write color equal to blue. Okay, so this is how I am going to plot the regression line on a scatter plot of MEDV versus CRIM. Okay, save. Why is it not saving? Alright, so the next question now is this. Fit a multiple linear regression predicting MEDV using the following variables. So now I just have to do model 2 equal to LM this remains same, MEDV. And I am regressing on these. So I am going to put these but separate by pluses. Okay, and then I am going to mention data equal to Boston so that they know which variables to look where. So model 2 is this thing. Here I have the regression coefficients for each of these independent explanatory variables. Okay. Now the next question is interpret the coefficients which variables are statistically significant. So the interpretation is, let's say, of crime rate in this case is that if all other factors remain constant, then increase per unit increase in per capita crime rate will reduce median value of homes by this much into $1,000. Okay, which makes sense. If an area is very high with crime rates, their prices should be low. Secured areas cost more. Okay, so the important part here is provided that all other factors remain constant. This is the more important point over here when it comes to interpretation. Okay, which variables are statistically significant? So to do that, we need to do a summary model too. So here we see against all variables we have at least 2 stars. So 2 stars means that if we take a level of significance of 0.01, even then that is satisfied. So if we have at least 1 star, we should be considering alpha as 0.05, okay, as the level of significance that is usually considered. So here, since we have at least 1 or more stars, so we can say that which variables are statistically significant? All variables are significant. Okay, the intercept is however not significant. Okay, which is somewhat strange, because even if we don't have any of these factors, housing price, there is supposed to be a base price involved. So we should be careful if in such cases we should totally do away with intercepts or not. But for the timing, for the sake of this question, we'll just keep it. The next question is, what is the adjusted R square? How does it compare to the R square from the simple model? Okay, so here we see that the adjusted R square is 0.6103. Okay, so in the previous R square it was 0.1506. So here, because of addition of different other variables, the R square has also increased. Okay, from 0.15 it has increased to 1506. But adjusted R square also adds a little bit of penalty when we keep on adding more variables. So here we see that even after adding that penalty, R square has increased significantly. Okay, so this is way more than r square of the simple linear regression. Okay, and which goes on to say that inclusion of these independent variables have actually improved the model. Okay, fine. Now, what are the key takeaways here in terms of housing price prediction? So in housing price prediction, we'll have to make the key takeaways with respect to basically two things. We should see which are the significant variables. Okay, we should see if the model is significant. Model is significant, how will we find out? Here we have the f statistic and the p value. So the model f statistic is this thing and p value is less than 0.05. So we say that yes, model is significant. Okay, and then we look at the individual variables. And we say that okay, yes, all individual variables are significant, and then we make interpretations based on their magnitude and direction. So as far as this is concerned, this crime rate, it is negatively impacting house rates. Okay, age of property is negatively impacting house rates, but RM is actually positively impacting. So if I just go and see what does RM stand for, so where is that Boston data set? We'll go and press F1. So RM stands for average number of rooms per dwelling. So if number of rooms increases, the prices will also increase. Okay, that is the interpretation. And then Zn is what? Zn is standing for proportion of residential land zoned. So if land is more, then the cost will also increase. So this is also in line with the real world situation. And then we'll have to make other inferences. But this intercept thing, a negative intercept doesn't make much sense. So and this is not even significant also. So maybe when we fit the model finally, we can fit it without the intercept. Now just to give it a try, let me just see how that would look like. If I do a model 3 equal to this thing, but I don't want the intercept term, so I am going to give -1 plus this thing. Okay, and then if I do a summary model 3, then also we see that all the other variables remain significant and the directions also remain same. So Indus is proportion of non-retail business. So if that decreases, the line the prices will increase, and similarly so on and so forth. Nitrogen oxide's concentration is having a greater impact because this is like increasing an increased concentration of nitrogen oxide is reducing or impacting the price rate by a greater magnitude. Okay, so that is how we should be interpreting these models. All right, and then if we have to try regularization techniques like ridge or lasso, we should use the library II lasso, and then we can use this model matrix. So let us say that this X is actually model dot matrix of
ஒரு நோட்டு நான் எடுத்துட்டு வரணும்ப்பா எனக்கு.
of this thing. Okay, so then X will have these four variables, these six variables, that is without the intercept, and then we'll have to see how this
ஒரு நோட் எடுத்துட்டு வந்தேன். இல்ல பாப்பா, நோட்டு பாப்பா, லாங் சைஸ்
should
நோட்டு.
be X, and then Y should be Boston dollar MEDV, and we can use these lambda mean ratio, we can set something. Let us try with n lambda, let us try with 5 lambdas, and then this is what the outcome looks like. So in these cases we have the standardized beta estimates, lasso estimates. These are the corresponding non-standardized beta estimates for different values of lambda, and based on whatever lambda we choose, if we choose this lambda, we are going to choose the corresponding column of betas, and then choose the intercept also, corresponding intercept from this A0 term. So if we choose the third lambda, then we have to choose the third A0 intercept, and then that is how we'll have the lasso regression. Okay, so this was all from my end. Please let me know if you have questions. So if there are no questions, then I would like to end today's meeting.
Excuse me, ma'am.
Yes, ma'am.
Good afternoon, ma'am.
Good afternoon.
Ma'am, I have seen your recorded video only. I don't have enough time at Sunday evening. Sorry for that. And every time while before doing assignment, I used to watch all your recorded YouTube videos in the presentation folder.
Okay.
But what's today's doubt is, so usually I use the software of 4.3 version.
Okay.
So in that version of R, I can't able to download. I can't able to install the package of iLasso. So may I know which software you are using for doing this coding, ma'am?
Yes, so I don't think you did get a chance to look at yesterday's video, but I'm going to show you right now what to do in such
Yes.
scenarios. So if you
Okay.
if you have this iLasso package, and it holds for everything, okay, so
Okay.
there are some packages which become which are deprecated and not always available. So as
Okay, ma'am.
so when you encounter such packages, I just typed iLasso R, and I
Okay,
go
ma'am.
to this CRAN package. I Can you see my screen?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am. So if you go to this screen, you will see that this was removed from the CRAN repository, and formerly available versions can be obtained from archive. So if you find
Okay, ma'am.
some statement like this, you need to go to click on archive, and
Okay,
then
ma'am.
you'll have two or multiple versions of previous versions of those packages. So
Okay,
if
ma'am.
I want to choose the latest one, let's say I am focusing on this one 0.0.2. So
Okay, ma'am.
what I can do is I can do a copy link address,
Okay,
and
ma'am.
then I can go to my R and write install.packages, and then within quotes, instead of giving the package name, I can give that
Oh,
package
okay,
address,
okay, okay, ma'am.
and this is going to install it in your system.
Okay, ma'am.
it
Okay,
it
ma'am.
might throw errors if it requires other dependencies. That also you have to install by doing install.packages, or just installing from however you want this to be installed, and that is how it will get loaded, and then just do a normal library thing, it'll work.
Okay, ma'am. Okay.
Also you can download this, save it in a proper folder, and then instead of using this URL, you can give the path to that folder also. That will also install this package.
Uh, okay, ma'am. Okay. If instead of install.packages, instead of the code, we can
You
use
can
this
give the
this one.
URL. Yes,
Yes.
you can use the
Okay.
URL. You can give the file path if you have some packages already downloaded in your system, so that will
Okay.
do the
First, I
job.
have to download this. Am I right, ma'am?
No, you don't need to download this if this
Uh,
URL is supposed to work. But
okay.
then
Okay.
you'll
Okay.
have to see whether that version is also compatible to your version of R.
Okay, mine one is so in that first video, first lesson, it is first video lecture. It is given as R software HTTP dot that version only. That is 4.4.3 version. So that
Okay.
only I am using, ma'am.
So
Is this
mine.
is this?
So this one I'll have to see what is my version. So mine is this thing. Oh, I can't even see here. How do I see the version? Let me see. If I just open my R, what the 4.4.2. This one is
Yes, ma'am. This
4.4.2.
is 4.4.2,
Yes, this is
ma'am.
also written here. See, 4.4.2.
Okay,
So
ma'am.
I hope this is compatible with your version also, because there are some packages which are not uh, I mean usable for certain very old versions. So I don't think it'll that case will arise with iLasso. But if you have something like this where the packages are not compatible, there would be alternate packages with which you can perform the same operations also. So you might have to search. I mean, I'm not talking about Lasso, but I'm talking about things in general.
Okay, okay. I think these things is recorded in a session. Am I right, ma'am?
Yes, yes,
So
everything is
if I have a
recorded.
doubt, means while doing that, so I can refer this video, recorded video. Am I right,
Yes,
ma'am?
yes, yes. This will
Yes.
be
Yes.
available
Okay.
online.
In Google, I have to search iLasso R. In that only that RQ comes. In that RQ, I have to select that
Yes,
um,
yes.
that version, that
I
URL. Am
can
I right, ma'am?
even
Okay.
send you the if you
Yes, ma'am.
that will be, I think, more helpful if
Yes,
I
ma'am.
send it here. So you can just click on here
Yes.
and get this
Okay.
downloaded.
Okay. Thank
Okay.
you. Thanks a lot, ma'am.
Thank you, ma'am, for
So
attending the lectures.
that is problem solving session is very helpful for doing that assignment, ma'am. Thanks a lot, ma'am.
I'm so glad to hear that. Thank you so much for joining.
Thank you, ma'am. Thank you, ma'am.
Yeah, thank you. Is there any other thing that you would need my help on? Okay, if not anything else, then thank you so much for taking this course, and please go through the lectures, and I hope you fare well in the final exams if you are taking them. Thank you so much for joining the session, and if you have further doubts, please post in the discussion forum and we'll try to address them. Thank you so much for joining. Have a good day. Bye bye. Thank you, ma'am.